Okay, so hello everyone. Welcome to the Toronto Machine Learning Micro Summit. The focus of this first Micro Summit of 2021 is finance. My name is Nadia and I work at Mehrnaz as a senior machine learning engineer. Today I'm honored to be here and to have the opportunity to introduce one of our amazing speakers. Before starting, I would like to remind you that if you have a question, please post it in the chat. I will collect all the questions and ask them directly to our speaker after the presentation. Also, if you haven't already, please complete your feedback so you can be paired better when using the networking function. So our speaker is Mehrnaz Shokrollahi. Mehrnaz is currently a senior data scientist at PureFacts Financial Solution, where she transforms financial data into reliable artificial intelligence. She has developed multiple algorithms and use cases for financial industries like boutique firms. Alongside her work on PureFacts, she is member of the advisory board on Queen's University Incubate program, first student-run AI startup incubator. She also holds a position in IEEE Canada with the title of Chair of the IEEE Signal Processing Section Toronto chapter. Since completing her PhD from Ryerson University in 2015, Mehrnaz has had various positions in different industries, including healthcare, manufacturing, and mobile app, and focused solely on developing AI solutions. She has also authored numerous papers and been awarded the prestigious scholarship, including MITEC's postdoctoral award. Please join me in welcoming Mehrnaz Shokrollahi.
Thank you very much for the introduction, Nadia. It is my pleasure to be here. So the topic of my today's presentation is investor churn detection using computer vision. So I'll start by giving you a little bit of description about myself. I'll go over the business problem with you and talk about the goals and the challenges that we have faced, the methodology that we propose, and some results and future work. So this is my name is Mehrnaz Shokrollahi, and I'm the Senior Data Scientist at PureFacts Financial Solutions. I actually like to give you a story. About a year and a half ago, I was part of the I was attending a Toronto Machine Learning Conference where still, conferences were allowed to be in person. And over there, I met two of my current colleagues at PureFacts. We talked, and one thing led to another, and here I am today presenting to you our work at PureFacts. PureFacts is a tech company who work closely with wealth management firms. We have different products and offerings, and our main offering is a fee calculator. For the past couple of years, we have extensively expanded our AI solution, and I'm part of the IES team, which is the Insight as a Service team, and over there we develop some of our machine learning and AI algorithms. Along with this picture is my son, Shayan, and my husband, Kiana, who have been with me in this journey for the past year with PureFacts. So just to give you a little bit of background in terms of the business problem you're trying to solve, shifting client demographics and preferences, as well as flood of digital offerings, are basically driving the clients around the world to reconsider their wealth management relationships. And since 2016, we have seen a surge of robo-advisors, and a lot of the younger generation, especially millennials or even younger, are making up the market because older people are in the retirement age, so they're basically creating that space for younger people to come in. As well, we have realized a shift in investors' need. A lot of our investors are really not looking for investment advice; they're more looking for holistic advice, where it's related to their financial well-being. So it's very important, and a lot of our wealth management firms are really on board for the solutions of our solution, which is for churn detection, and they know that they have to kind of get quickly onboarded and get quickly adjusted to the change that the market is seeing. And as well, the fact is acquiring, new clients, and depending on any study, you believe in or any industry you are at, acquiring a new client or a new customer is 5 to 25 times more expensive than retaining an existing one. So that's why it's very important for our financial advisors to be able to detect and to be able to recognize that need. So one question that we ask is, what is exactly churn rate? So churn rate in different industries is defined differently, but in general, it's the percentage of customers who end their relationships, in a company for a particular period. And in wealth management, we usually refer to the churn rate as it's usually measured by months or a year or a quarter. However, we don't see, in wealth management, we don't see a big churn rate. We don't see a lot of our clients leaving, but the impact, the business impact that these clients churning has is very big in terms of, the revenue or the money that the people who are churning could potentially take around $500 million of assets under the management, or about $30,000 to $40,000 of fees. So that's the impact that we can see. That's a pretty huge impact. We also, the question is, I already talked about the business problem, but the question could be, what are the major reasons for a client to churn? And the top three I listed here are poor customer acquisition efforts, poor customer service, and poor offering. And generally, those refers to, for example, you as a business, you have industries that promote, price heavily upfront, and so a lot of the clients or their customers that they attract, we call them deal seekers. And these clients are generally will switch to different firms the moment they find a new deal. The second one, which in my opinion is probably the most important part, and a lot of people may not pay attention to, is the poor customer service. Actually, we partner with Simon & Kucher to understand what is the effect of customer service. And what they have shown is that 89% of customers will leave and go to the competitor after a bad experience with the customers, with the service that was provided. And 59% of those clients who with the age of 25 to 35-year-old will report that online. So this not only can lead to clients churning, but also can lead to a lower client acquisition. And the last one, poor offering and pricing. So for example, people or businesses that they don't understand their clients' need, and they don't understand the client segmentation, so they offer some wrong, basically, products or wrong offerings. And that could lead to, the client's journey. But this is, these are the three major. But in financial and wealth management firm, we see even more than that. There are type of, life event that happens in a client's life. So for example, our investors are getting married, so now they want to switch their financial advisors and go to a different firm to be the same account or have the same firm as their spouses, or they have lost their job, so now they're forced to come out of the wealth management firm that was basically used by their previous employer. Now they have to force out to come out, or people are retiring. So there's a lot of other factors that could be affected in a wealth management domain. So in order to prevent something like that, so we need to, we need to understand our clients. We need to understand their needs, their pain points, and then we need to basically tailor and personalize the offerings to them. And that's exactly the reason, a lot of our financial advisors are again on board with our offerings. And now we have seen the role of finance or ML in finance, and whoever is basically in a financial domain, and I think a lot of you guys are in the financial domain. You know that in finance we have a lot of regulations and we have a lot of compliances. So ML has actually, so it has been a little bit slow in terms of the machine learning domain coming into the finance, but I think it's picking up, and we have seen about 46% of large fintechs and more than 30% of large financial institutions like banks are identifying AI as one of their source of income for the next 12 months. And that's why we have seen a lot of different applications and use cases. In a retail banking, we have seen, credit card approvals, loan approvals. We have seen in wealth management. We also have seen a dynamic portfolio building, even easier onboarding and platforms and more digitization. So and companies are understanding that this is the future and the new beginning. So our goal in general is to predict client churn in wealth management firm, and from what we have understand from the data, from the model that we create, we want to be able to give that feedback to our financial advisors and to see, to basically help them identify what are the reasons, the clients are churning. So not only we want to help them identify the clients, but also what were the reasons behind this. And then, so for that, they can, provide that feedback given to our financial advisors, and they can go and do the tasks that they are supposed to do to prevent the clients from churning. So if we want to talk about in terms of a data point of view, what we want to do is we want to get the data, which is based on a financial domain. We want to train a model, and our model is a supervised classification algorithm, because we want to classify our data or our clients into whether they are going to stay with the firm or leave the firm, and then predict the probability of how much our clients are what is the percentage, or what is the probability of our clients churning. Speaking of data, we have different type of data. We have client financial data, which includes, the daily holdings, daily trades, how many transactions they have done, how much transactions, withdrawal, deposit they make on a daily basis, how much fee they pay, the rebates they receive, and also, the rate of returns, that they receive for their wealth. And we also have access to the market data, and the market data is basically the stock market, how the stock is, or how the market is changing over time. And I think for the past year, we have seen a crazy market. So we also have access to that data. And the last one is the CRM and the KYC data, which is mainly referred to, client relationship management and know your client. And these data are, in my understanding, or in my belief, is that these are the most important type of data that we can have for our clients, so that we can have a sense of who our clients are, which is, what is their age, what is their gender, what is their marital status, their preferred language, who's their financial advisors, and also, what is the risk tolerance? Are they a low risk people or the high risk people? So it gives us a more understanding of our clients. Now, we have seen, I think it really doesn't matter on what domain you are in. Financial or finance is not my domain of expertise. I have been in different industries, but my main industry that I worked for a longer time was in biomedical applications, and we also had similar issues and similar challenges, and I think so these challenges are probably the same throughout different industries. But first of all, we are looking at imbalanced data, and imbalancedness, as I mentioned, we don't have in wealth management, we don't have a lot of our clients churning. So the rate we are looking at is 5 to 7% on a yearly basis. So that makes our metrics that we want to evaluate, our models, prone to a lot of, it's harder to basically evaluate. And because we want it to be consistent across all the methods that we develop, so we had to use just certain algorithms for our imbalance problem. Also, our data is very sparse, and again, this is sparsity. We have seen it in other applications, but in general, the sparsity comes from that not all of our clients or customers are making daily or monthly activity. So a lot of the information is missing because they did not, do any transactions for months, or some of also our KYC and CRM information are missing because the financial advisor, did not fill that up at the beginning of the onboarding of the client. And also, as the AI become more and more popular, so is the access to the data become less and less it's basically access become more and more harder, and I think that's true for probably a lot of you guys here, that we have difficulty getting the data. So access and having a good set of data points is always a challenge. And of course, we are having data points that are time dependent. So historical information is very much important. We want to be able to look at all of the data that we have for all of our clients and see how over time, what are the reasons or how the data points change over time, so we can basically predict whether they are going to churn or not. And the last one, I think, which is the main important part, is usually as a data scientist, we don't necessarily do all the due diligence in terms of checking how the model is performing while we go in production. So we have often seen that our models are perfectly working, we have good accuracies, but when we go on production, we fail to recognize or predict the event. And that is the reason, because for many of us, we do a random selection, and we randomly, kind of divide our data into train and validation set, and then when we go in production, the time information, over time our data changes, so that time information is missing. So in production, we don't see the performance of the model as accurate as when it was offline. So one of the things we proposed in our methodologies, and not only depending on this, but also in any other algorithms that we develop, is that we split our data over time, which is, we call it a chronological split, where we make sure that over time, our data and how we validate it, it's basically divided by time. And we do have different testing strategies, because at one time maybe we get a better performance compared to the other. So we test over multiple months or multiple time in our database, so that we get as close as possible, as close to production scenario as possible. Now, so basically our solution is, what we want to do, our proposed algorithm is, first of all, we are interested in historical information. So we want to be able to use all of the information for every client as much as possible. So usually what we have done is we have looked at a snapshot of our data at a given time. Now here we want to look at all of the information. And also, we don't have access to a lot of data. Now, data sample is quite small, and we have an imbalanced kind of data set. So what we want to do is we want to use algorithms or methods that allows us to augment and manipulate the data, so that we can increase the number of samples. And of course, a lot of our clients are very small. So we call them white glove boutique firms. So these financial firms are just looking or working with very small or limited number of clients. And also a lot of the firms that we are going to work for are just new in the business. They just came in, a couple of years now, so we don't have a lot of historical information. So we want to be able to use algorithms and methods that can allow us to use transfer learning. Basically, we train on a model and use the parameters of our model to and transfer it to a new data set. And again, because we are not looking at a snapshot and we are looking at a total, data for every client, we basically have one label per client, whereas before we had multiple labels for one single client. And that was because we were looking at snapshot, and at that given point of time, a client was still active, but at the future, the client was non-active. So we were not looking at the historical information about that client. So In a machine learning term, what we have done basically and what we propose to do is that we are getting the data, which again is the financial data. We do some due diligence and some data analysis and data analytics. And then what we do is we basically group by our object, our clients. And when we group by our clients, we have for every client, we have a basically one set of features or a data frame. And then what we propose to do is that instead of, just use that to predict, we convert that to an image. Then with an image, we can do a lot more. We can do augmented, we can do, add noise or distortion to our image. We can use transfer learning. And then we can use, deep learning algorithms to train our model and to predict the client churn. So in the next few slides, I'm just going to show you some of the data analytics that we have done. It may not do the justice of how much data analytics we have done. We have done extensive data analytics and we have provided insight to our clients, but just to show you a little bit of how our data looks like. So this graph is show you one of our features, which is whether a feature, whether that client is female or not. So 1 refers to it's a female and 0 refers to it's not. So what we see is that most of or majority of our clients are not female. However, when we look at the data for those female and non-female, when we look at whether they have churned in the next 12 months or not, we see that for both of our clients who are churning, we have the same number of, or the fraction of churning is the same for both female and non-female, and that kind of makes us a little bit, the data is not too biased regarding, whether female or male are concerned. We also look at the churn rate within the 12 months over different months. So on the x-axis, we have different periods, and we show that what is the fraction or the percentage of the users churning over the next 12 months. And we see that, on average, we have around 5 to 7% of our clients, leaving months over months. And also I looked into, as I mentioned, we have a lot of data that is sparse. So then looking at the fraction of missing values, so we actually, as you can see, more than 80 of our features, we have about roughly 500 features, and about 80 of our features have more than 60% missing values. But a lot of our features were converted, especially for the KYC and the CRM information. They were, sorry, not the KYC information. Most of them were converted into binary format, so you can see that not a lot of our features have less than 10% of missing information. So when we converted our data into image, as I mentioned, we are focusing mainly on a chronological splitting, because we want to make sure that we are dividing our data into a system that is defined by time, because over time these data points are changing, and we define a strategy for our testing strategy, we call it, and that is that we, at least for this work, we wanted to test our models for different months over time. So we kind of like a rolling window of different months, and we tested how the model performs over different months. And at the end, the average of out of all of those months, which is 24 months, was the average of our prediction results. On the right, you see 2 images of our conversion when we convert our data frames for an active client and a churn client. Our images are in black and white, so just for the sake of visualization here, I've changed it to a colored one, but it's a black and white image, and we normalize our data, and this is the input of our deep learning model. So the model that we have designed is a very simple model, a two-layer deep neural network. We actually develop our model using PyTorch, and we have used optimization to find and tune our hyperparameters. And we are definitely tracking our models and our performance of our training and validations using MLflow. But the model that we have used is a simple model, and the reason for that was that, again, even though we have used and we have augmented our models, we have increased our data points, and we have kind of solved the unbalance problem, but still our data points are quite small, so the model will overfit pretty quickly. So in order to avoid the overfitting, and in order for us to be able to kind of predict and the model to be more generalized, we use a very simple model, and a number of neurons that we use are also small. So here is the graph of how our algorithm work. And actually, I forgot to mention the metric that we use, and again, because we want to be consistent across all of our methods that we have developed, not only in the deep learning domain, but also in tree-based algorithms. We are using AUC, which is the area under the curve, the ROC AUC measure that's very well defined for when we have imbalanced data. So you can see that our strategy in our testing strategy is to test over different months. Over months, we tested, and the best metric that we get, we are getting roughly high 60s to low 70s. Again, deep learning models require a lot of data points to be able to work well, but this is on average, that's the accuracy we get, or the AUC we achieve, and that's only on the testing data or validation data. However, when we look at the impact and the business impact that our model has created, for all of those that we predicted as a highly potential or high churning clients, we have realized that our results have basically the increase in churn led to 5 percentage point increase in the fees loss, and 1 point decrease in AUM, which is the asset under management, in 2019, which roughly correspond to about $450 million of AUM and around $32,000 of fees that the client have or will lose if they don't make any actions for the clients that have churned. So the business impact is quite important and big. So in conclusion, we have successfully developed a new ML model, and we use computer vision to basically transfer our data into images and use deep learning models to predict. And we show that the business impact that our models could have, it's pretty significant. As I mentioned already, with deep learning models, usually they work a lot better as we increase the number of samples and data points. So we are going to test and basically use our algorithms as we onboard new clients, and of course increasing our computational resources in order for us to be able to test and to do more hyperparameter tuning to find the best model and increase our AUC. With that, I am going to conclude my presentation. I really thank you for your time and your basically being here. So if there's any questions, I would definitely take it.
Okay, so thank you so much for your presentation. It was really, really interesting. So I see a lot of questions. So I'll start from the first one that says, can't all wealth data of a client be stored in a database when they onboard?
Sorry, hold on, let me bring the question myself. Can you repeat the question again?
Yes, so it's asking why the wealth data of a client cannot be stored in a database when they onboard.
They will be saved on when they onboard the new clients. The data are being saved, and so we are working with the financial advisor, so our clients are not the investors. Our clients are the wealth management firms, and over there, when they onboard their new clients, they gather all their data. Some of these data points are from a long time ago. These clients have been in business for years, so a lot of the financial advisors at the time, they did not collect all of the data from those advisors. But I think from now on, from the past few years, any data points, any investor that comes into their system, they will collect all of the data.
Thank you so much. So Shrikant, if you have any follow-up question, please post it in the chat. I'll move to the next one. So I'll move to the next two because they have like similar topics. So what are the benefits from converting data to image to apply transfer learning to derive predictions on a smaller data sets?
That's exactly the benefit. So the whole point for us was to use, because again, as some of our clients are just very new into their business, they just came in and they are starting to onboard new clients, they're acquiring new clients, so the database is very small. Not only is it small, but also it's very short because they just came into the business. So we want to convert our data into image so that we are able to use, it's not even in a computer vision algorithm, we can use any deep learning algorithm to convert our data into a system that we can eventually learn and use that for transfer learning. I hope I have answered that question.
Yeah, if that answer was not enough, please post a follow-up question in the chat. So another question is, will you lose model interpretability when converting to images, especially when your data wasn't an image to begin with?
For sure, and that's one of the challenges that we have, especially in a deep learning, scenario. It's always harder to interpret. We are actually in the process of developing some interpretability tools. We have already developed that for non-deep learning algorithms, one of the algorithms we are using mainly is a LightGBM, and we are using SHAP values to interpret the model and to see the feature contributions. We haven't really started that, but that's one of the goals that we have, is to use the SHAP values for the neural network as well, to understand the features and the feature contributions for our predictions. But definitely we lose that, and that's one of the challenges that we have for when converting to images.
Thank you so much. So next question is this model currently used for decision making?
It is not. So this is a proof of concept. We still are adding more data and trying to increase the performance of the model. As I mentioned, our model that's in production is a different algorithm, but this was a unique way of using machine learning and deep learning for this specific use case.
Okay, thank you so much. Next question. Could you reveal a bit more about the number of features you use in your model, and how do you use noise and augmentation?
Sure. So we actually have different types of, as I mentioned, we have different types of features. With the current data set that I showed you, we have it's a bigger data set in terms of we have a lot of data for our advisors. So who are these advisors are? So originally the feature size was around 500 features. However, because the advisors is very sparse, not sparse in a sense that they're missing, but sparse in the sense that, one client has one advisor, maximum maybe two advisors. So what we have done is I have removed basically all the advisor information. So at the end, we have around 200 roughly features, which again, we do a lot of feature engineering, and we do a lot of feature analysis in terms of, understanding what features are more important. And again, with the size of the image, we had to make sure the size, when we want to convert to an image, the size is retained the same. So the number of the rows in our image are basically the period. So we wanted to make sure that all of the our images have the same size. So the number of rows and the number of columns, which are the features, as well as the features are basically are in the same same order, because if the feature order changes, then the image will basically have a different meaning. So we make sure that the order of the features remain the same throughout all of our data analysis or conversion.
Thank you so much.
And for the noise part, the question was, how do we do noise? So in image processing, you know, you can flip your image, you can add distortion, you can, you know, any sort of image processing similar to all the other ways of doing noise and distortion to image. That's how we distort and increase our database.
Thank you so much. Okay, next question. We have so many questions coming. Any comparison with other benchmark model performance and with other ways to overcome imbalanced data such as resampling?
Yeah, we actually looked into resampling. Unfortunately, resampling, again, is one of those approaches that may not necessarily give us the right answer when we are in production in a scenario. So resampling was not an option for us. We did not apply resampling. Our benchmark model is LightGBM, as I mentioned. So we are using LightGBM, and we are getting a better performance with LightGBM because it already converts some of the missing information, and the tree-based algorithm works better for this use case. And again, because of the number of the data points that we have and the sparsity of the data, for now we are not getting the performance, but I think this application could definitely work a lot better as we onboard new clients. So our benchmark is LightGBM.
Okay, next question. Did you also try simpler approaches to handle imbalanced data like rows, downsampling, or weighting, and use regular ML models like LightGBM that you just mentioned for prediction rather than using convolutional models with data converted to image? So I think you kind of already answered, but if you have anything to add, please do it.
Yeah, exactly. So this was our proposed approach, and we wanted to make sure, and we wanted to leverage some of the challenges that we have. Again, historical information with LightGBM. We are not looking at the history of the clients. What we do with the LightGBM, we basically look at a snapshot. We look at a given point in time, what are the features for this client, and whether this client are going to churn in the next 12 months or not. So that was not including the historical information. So with this idea of using images, or even like using a data frame, and necessarily we did not only stick with the images, we also tried different algorithms like LSTM or other deep learning algorithms as well. But we wanted to make sure that we have information for every client on a separate basis, which is including the historical information. One of the other ways we have done is that we also, try to extract and to do feature engineering to include the historical information. So, the rating change of, clients, doing transactions, all of those we also feature engineer, but it adds a lot of complexity to the model. It takes longer to train. So that's one of the reasons we wanted to convert to a deep learning algorithms or a data frame that can be used and that could use the historical information maybe.
Thank you so much. So the next question is, have you seen any evidence of your clients making changes to their business model after working with you? For example, if you identify that the low-risk single women have higher churn, are advisors moving away from working with those clients?
We are in the process of receiving feedback from our advisors. It's a new project, so we are getting that feedback back from our advisors. But definitely, we have thought about that, and we have looked into how we can, kind of understand the effect of our models to the advisors' decisions, and how those decisions are, going back to what they want to do next. But definitely this is a process that we have thought about it, but still, because it's so new, we still haven't reached that, or we don't have the proper data points to analyze those things.
Thank you so much. So now we have a technical question. How is the conversion to image done? Which algorithm are you using? Also, what type of image are you producing?
Sure. I think I show you an example of the image right here. So that's when we convert the image. The tool I'm using is just the Python packages, the scikit-learn package that I convert to image. Yeah, so algorithms and tools is just the Python packages, and the images are black and white. So I convert to a black and white image just for the sake of visualization. Here you see it's a colored image, but it's a black and white image, and I've normalized them. So the values are between 0 to 255 after conversion, and then I have normalized them as well.
Okay, so they were asking for an example. You also have the example. Thank you so much. We have a last question. And have you guys created models to predict whether a client will convert?
Sorry, what do you mean by client converting? Means staying?
I don't know. There is no explanation here. So Jerome, if you can please add more detail and explain what do you mean with convert, it will be very helpful. Meanwhile, I just got another question. So what does the white line in the image represent?
So the white lines are basically data points. The black, again, it's the black and white. The black means it's either it's 0 or there's no information, because with the one of the things that we have to do, we have a lot of information that are missing. So we had to do extensive data analysis to understand what imputation techniques we want to use for different features. So one of the so for different features, we actually impute different values, or either we remove the feature completely or imputing with 0 values. So the white lines are generally the informations, or there are some values for that, and the black are the zeros.
Awesome. Thank you so much. So we don't have any other information about Jerome's question. So, and we don't have any other question. He might probably be already attending another session, because I think they have already started. Yes. So I would close here this amazing session, because
thank you very much.
Thank you so much for being so willing to explain details and to provide all the information people asked during the question. So thank you so much for everyone for attending, and yeah, I'll see you to any other talk. Thank you so much.
Yeah, thank you, everybody. Have a great day. Bye-bye.